Hello friends, Mr. Burrell here, where we've been talking about solving all sorts of different kinds of equations that include exponential expressions and logarithmic expressions. We've talked about solving exponential expressions a little bit by converting them into logs. We've talked about properties of logarithms, expanding and condensing those logarithms. We've talked about solving basic logarithmic equations. Now we're going to take a step further, and this concept is titled Solving Logarithmic Equations Requiring Exponentials, but really any other type of logarithm equation that you will see, we're going to cover on how to solve that type of logarithm equation in this lesson. So that's what we're doing. That's what we're about today. I hope by the end of this lesson that you're able to use properties of logarithms to combine logarithms. So there will be some of the problems where we have to use the properties we know about logarithms to condense or expand a logarithmic expression in order to help us to solve it. I also hope that you're able to rewrite a logarithmic equation to an exponential equation. We've done this already, except backwards in the first section that we talked about in this unit. We talked about converting an exponent expression to a log expression to make it easier to solve. Now it's going to be helpful to solve by going backwards, writing a logarithmic equation as an exponential equation. And then also I hope you're able to solve logarithm equations with a calculator, some of the basic ones. Okay, so let me move this down so we can see everything that's happening here. We've already solved some basic exponential equations like this. We did this in the very first section of this unit. Subtract 4 on both sides and get 4 to the n power equals 98. And then I have to convert this to a log. So n is equal to log base 4 of 98. We've talked about this, and that way, when I had a variable and an exponent, it was really handy to change it into a logarithmic expression, because I can do this. I can solve this. So we've talked about problems like this. We've also talked about solving some basic logarithm equations like this, where I have log base 17 of this is equal to log base 17 of this. We talked about since these have the same base, then their arguments, or what's inside the parentheses, also have to be equal to each other. So we could basically just ignore the logarithms and solve for x this way. We've talked about that. We have also learned how to expand and condense logarithm expressions like this. We talked about the product property, and we talked about the quotient property. When I have log of 5 times 8, it's equal to log of 5 plus log of 8. Or if I have log of 10 over 12, it's equal to log of 10 minus log of 11. Or sorry, log of 10 over 11 is equal to log of 10 minus log of 11. Those are all things that we've discussed. Those are all things that hopefully we're comfortable with. So now we're kind of going to combine all of those tools into one problem. We're going to combine all those tools into one problem. If you remember these, again, I mentioned these just briefly on the previous slide, the properties of logarithms, especially this one and this one are going to come in real handy in today's lesson with the problems that we're going to try to solve. And also, as I mentioned before, we solved problems where it was convenient to change from exponent form to logarithm form. Today, the problems we're going to solve, it's going to be really helpful to be able to convert from logarithm form back into exponential form. So keep both of these boxes in the back of your brain if you need to reference back to this page or back to the pages where these are at in your guided notes. As we're doing these problems, please feel free to do so. Okay, again, we're going to combine all of these tools, all these logarithm and exponent tools that are in our tool belt into one single problem. There will be a couple different varieties that we'll see. So let's start simple. This problem is not in your guided notes. I think this is actually a homework problem. This is number 1 in your homework. So if you already have the homework printed and you want to work on this as we go, or if you want to reference this video later while you're doing your homework, please feel free to do so. So I have log of 2 plus log of x is equal to log of 8. So this looks similar to this problem right here, except now, here I just had 2 logs, here I have 3. But what do I know about when I have 2 logs that are added together? I can use this product property of logarithms to condense that logarithm into one single logarithmic expression. So log of 2 plus log of x is really log of 2x. So log of 2x is equal to log of 8. And since these both, again, when there's not a base here, I'm assuming this is a base of 10. Since both of these logarithms have the same base, I can basically drop the logarithm off and write 2x equals 8. And when I do that, I divide by 2 on both sides, and I get x equals 4. So log of 2 plus log of 4 is equal to log of 8. So that's a simple example where I just use my condensing logarithms property, that tool in my tool belt, to help me solve this problem. But what about something like this? These ones are in your guided notes. There's a 1, 2, 3, and a 4 in your guided notes, you might notice. And I'm going to work backwards. So I'm going to start with number 4 here. We're going to start with number 4. And we're going to solve each of these equations using all the different tools, all these different properties that are in our math arsenal and our math tool belt to solve these different problems. So ignoring this side of the equation, what do you notice here? I have a log plus another log. Since they have the same base, I can use the properties of logarithms that I know, the product rule, to condense those together. So log of x plus 7 plus log of 10 is really the same as log base 9 of, I'm going to write like a little bracket here so I can keep things straight, x plus 7 multiplied by 10. I take this argument multiplied by this argument. So log base 9 of x plus 7 times 10 equals 2. Okay, this problem is a little bit different than the one we did on the previous slide, notice, because there's not a log on this side. So here I have log of something, log base 9 of, I don't know, call this question mark for a second, equals 2. Where have I seen that before? Where have I seen that before? If I'm trying to find out what this number is, what do I need to do? Well, if you remember, I know how to change from logarithm form into exponential form so I can solve for this argument right here, this variable that's the log is being taken of. So if I come back over here, log base 9 of x plus 7 times 10 being equal to 2, I can change that into exponential form. So x plus 7 times 10 is equal to 9 to the second power. So I'm going to convert that. I just converted it to an exponential expression. 9 to the second power is equal to this right here. Well, now, I don't even have any logarithms anymore. I can just simplify and solve for x here. So I'm going to distribute 10 into both of the elements of this parentheses and get 10x plus 70 on this side. On this side, I'm going to have 9 squared, which is 81. So I want to get all my x's on one side, all my numbers on the other side. So I'm going to subtract 70 on both sides and get 10x equals 11. 10x equals 11. I divide by 10 on both sides. X is equal to 11 over 10, which is 1.1. It says round to 3 decimal places. I only have 1, so I just need to round 1.1. So take note of all the tools that I use there. Right here, I use my logarithm property of condensing logarithms. To go to this stage right here, I used converting from logarithm form to exponential form. And then here I used the basic rules I already know about solving an equation. Bunch of tools that I already have in my tool belt just combined in one problem. Okay, now I want to look at number 3. So this problem looks really similar to this one. So I have a log minus another log equals 1. Well, this looks a heck of a lot like the quotient property when I'm condensing logarithms. So I can condense log minus log into a single log. Log of x minus log of 5 is log of x over 5 equals 1. Well, this log is technically a base of 10. So I can convert that log into exponent form. X over 5 is equal to 10 to the first power. Take 10 to the power, 10 to the power. These cancel each other out. I get x over 5 equals 10 to the first power, which is just 10. See what I did there? Just converted to exponent form. So now I have x divided by 5 equals 10. I undo division with multiplication, so I'm going to multiply by 5 on both sides and get x equals 50. X equals 50. Yeah, notice the tools that I used. I condensed my logarithm using what I know about the different properties of logarithmic equations. I converted forms from a log to an exponential equation, and then I solved. Okay, so those just used condensing and then changing to an exponent. Let's look at a couple other examples. Again, I'm going to go to number 2 next, and then we'll do number 1. So again, this one right here, I can condense those logarithms together. Log base 2 of x minus 7 times 7 equals 2. Then I can change this log into an exponent equation. X minus 7 times 7 is equal to 2 to the second power. Or 2 to the second power is 4. Then I'm just going to solve this equation like what I would a regular linear equation. I'm going to distribute 7 into both of these terms and get 7x minus 49 equals 4. Get all my numbers on the other side. Add 49 to both sides. I'm going to get 7x equals 53. Then I need to divide by 7 on both sides, and I get x equals, I think it's 7.57. 7.57. Again, I condensed my logarithm using the properties of logarithms that I know. I converted to exponent form using the changing forms formula that I know, and then I solved. Okay, the last one on this page, the last one in your guided notes is this one. This one is a little bit more intense, but still following the same properties. First, I'm going to combine or condense these logarithms together. So log of this minus log of this is equal to log of x squared plus 5 divided by 6. When I take a log minus a log, I take the log of x squared plus 5 over 6, and that's equal to 1. Now that I have it condensed, now I can convert this log into an exponent equation. So x squared plus 5 over 6 is equal to 5 to the first power, which is just 5. So you're probably starting to notice, since there's a squared here, I'm also going to have to pull out my factoring quadratics, my solving quadratics tool out of my tool belt to finish solving this problem. Because now that I've taken care of all the logs, all the exponentials, now I have a quadratic expression. So I'm going to go ahead and multiply by 6 on both sides, get x squared plus 5 equals 30. And then, let's see, I'm going to go ahead and, this one actually isn't as bad as it looks. I'm going to subtract 5 on both sides and get x squared equals 25. I can solve this exponent expression using what I know about square roots. So I'm going to square root both sides. X is going to be equal to positive or negative 5, because remember, when I take the square root of a number, I can get the positive or the negative result. So x is equal to 5 or negative 5. Pretty cool, I think. I think that's pretty awesome, combining all these tools into one single equation. So many things you've learned in your entire math career history, from solving linear equations, solving quadratic equations, solving logarithmic equations, solving exponential equations, condensing and expanding logarithms, all these different tools all in one problem. I think that's pretty cool. Okay, there's a couple more I want us to do, just some unique looking kind of situations. These ones are not in your guided notes. They are in your homework though, so if you would like to follow along or reference this video later to help you with these problems on the homework, you may. They're numbers 8 and 10. So, following the same pattern, first I'm going to condense these logarithms together. Log base 2 of 5 over x minus 5 equals 1. Next, I'm going to convert this logarithm into an exponent expression. 5 over x minus 5 is equal to 2 to the first power, or just 2. Well, now I have this expression in the denominator. I'm going to need to multiply by x minus 5 on both sides. So I'm going to have 5 equals 2 times x minus 5. Okay, well, I'm going to continue to just solve this as I would a linear expression. I'm going to distribute 2 into both of the elements of this parentheses. 5 equals 2x minus 10. I'm going to add 10 to both sides. I'm going to run out of room. I'm going to get 2x equals 15. Then I'm going to divide by 2 on both sides and get 7.5. So my final answer there is 7.5. And notice again all the steps that I took. Not anything terribly different. I condensed my logarithms here. Then I converted my log to an exponential. And then I solved using what I know about linear equations. Okay, let's solve number 10 from your homework. I have log base 6 of x minus 9 plus log base 2. Oh, this is supposed to be a 6. I'm so sorry. I meant to change that. Log base 6 of x plus 7 equals 2. This is a good learning opportunity. If these were not the same base, I could not condense those and I could not finish solving this with the information that I know so far. These bases have to be the same. So I can combine those logarithms. Log base 6 of x, I'm going to put this like this, x minus 9 times x plus 7. So I multiply these arguments. When I condense two logs being added together, I multiply their arguments like that. Equals 2. Well, now I need to convert this to an exponent expression. So x minus 9 times x plus 7 is equal to 6 squared, which is 36. Okay, I'm going to multiply these out right here. I'm going to multiply these together. I'm going to get x squared plus 7x minus 9x minus 63 equals 36. So I'm going to go ahead and combine these together. And then because this is going to turn in, notice this is turning into a quadratic expression, I need to set it all equal to 0. So then I'm going to minus 36 on both sides. So I have x squared minus 2x minus, I think that's 99, equals 0. So now again, I need to pull out, it's a little dusty, I know, brush it off. We need to pull out our solving quadratic expressions tool out of our math toolbox in order to solve this problem. So I need to find factors of negative 99. I'm going to run out of space. I'm going to erase some of this. I need to find factors of negative 99 that add up to negative 2. So let's find some factors of negative 99. 1 and negative 99, 3 and negative 33, 9 and negative 11. I think there might be one or no, I think that's it. Negative 1 and 99, negative 3 and 33, negative 9 and positive 11. Notice right here, 9 plus negative 11, or 9 minus 11, is negative 2. So let's set this up. If you need to factor, we're going to use factoring by grouping, so I'm going to set this up as x squared minus 11x plus 9x minus 99. I'm going to factor by grouping. Out of this first one, I can take an x out and be left with x minus 11. Out of that second one, I can take a 9 out, a positive 9, and be left with x minus 11. So my final answer is, I'm running out of room, I apologize so much. Let's see, x minus 11 times by x plus 9. And remember, that was equal to 0. So my answer, my final answer, is x equals 11 and x equals negative 9. Because those are the values that I would put in here that would make this expression equal to 0. And that's it. Again, you can reference this for your homework. But this is, the next concept we talk about is real-world application of using logarithm and exponential expressions. So this is really the last of the nitty-gritty algebra work. So we've used all the tools, everything basically that we've learned in the last 2 full units to solve these different types of problems, even previous units. We've talked about solving exponent expressions, logarithm expressions, condensing logarithm expressions, expanding logarithm expressions, solving logarithm expressions, using all of those other tools. So hopefully by the end of this lesson, you can use the properties of logarithms to combine logarithms and rewrite a logarithmic equation to an exponential equation. Those were the main two tools that we used here. We didn't use a lot of this because most of the logarithms we needed to solve using exponential equations. But I hope that you have a better idea of how you can combine and use all these different tools to solve these different types of equations. So I hope that was helpful. Please remember, if you have questions, to chat with me during our Zoom conference, or let me know if there's another time that you need to talk to me. And I hope that you enjoyed that as much as I did.